Okay, so welcome back, and today we're going to introduce natural logs. So a natural log, remember when we were talking about exponential functions, and towards the end we talked about the natural exponential e, okay? Well, e comes back in logs because we can have base e as an exponential, we can also have base e as a log, and so and in fact, the log base e is the most frequently used log out there because e comes up all the time in all the sciences, in the natural sciences, in physics, in engineering. So a lot of times you're going to use e. So it's the most used log base e. Okay. Now, so this is how it looks as log base e. Now we could write this again. We could write this in equivalent form as an exponential form. Is going to be e to the y equals x, right? So again, base e. Okay, now, this also has its own symbol. Okay, so instead of writing this, we don't write this. What we write is ln of x equals y. So this represents the natural log. So whenever you see ln of x, we're dealing with log base e. Now, the cool thing is that you can get you can get all of the natural logs using your calculator. Okay, in fact, you've got an ln key right below, usually next to or right below, or it's there. So if you notice, there's my log key, my common log key. Well, there's my natural log key. Okay, so it's on most calculators. I would be surprised if it's not on any of the graphing calculators out there or a professional calculator out there. Okay, so that being said, now there's a couple of things that that I want to mention and go over with you because. Remember I said that log functions and exponential functions are inverse operations. So here's something to keep in mind. Okay, so if you look at a log function, for example, e to the x equals y, right? And we take another log function, we say natural log of x equals y, right? Well, the fact that these are inverses of each other means that, hey, if I take the log right here, right, so if I take the log of this, so I take the natural log of e to the x, like that, so I compose them, right? Then what happens is they undo each other, right? Inverse functions undo each other, and what I get out is x. Okay, so remember that. And this is true for all x. Now again, remember, the domain and range of a logarithmic function. So we know that the domain of this function is all x greater than 0, right? And we know the range of this is all real numbers, okay? So this is going to be true for all x. What else? I think there's something else I wanted to address. Okay, but this is going to be important later on when we start talking about solving logarithmic equations and exponential equations. We're going to use this property of composing these two, since they're inverse operations. It's going to help us solve equations of this type easily. Okay? And we can also exponentiate both sides here too. And it's the same thing. So I could say e to the natural log of x, right? And this is going to equal x as well. Okay? So we'll do more of that later. Okay. Have a great day.